Hello, I'm Danesh, Assistant Professor in Department of Architecture at the University of Hartford. Today, I want to talk and share my experience in one of my courses in University of Hartford. And the topic of my reports here is integrating and applying advanced sustainable architecture into architectural design studio. I'm also present this research on behalf of my two colleagues, Professor James Fuller, Associate Professor and the head of the department at the University of Hartford, and uh, Somaï Sadiq Hamidak, assistant professor at the same university. This report highlights applying theoretical knowledge of sustainable design to practical design projects. So I taught the lecture course, and the course is Environmental Systems for Architectural Design, and the course number is ADT 241. And we have a collaboration with another course that's a design studio, which is ADT 244. The assignments in the environmental systems for architectural design actually has a very strong tie to the design studio course. Based on the project, based on the pace of the class in the design studio, I defined the assignments in ADT 241. So there are always a relationship and a strong tie between the two courses. So the students, what they have learned and the lecture course, bring it to their design studio classes and use it. And that's the class, both class, the lecture class and the design studio were in the spring 2024. In the ADT 1241 or the lecture course, the students mainly work with two applications. The first application was Autodesk Forma, which is a very brand new application for the design analysis or site design analysis. So students for the first couple of weeks use the Autodesk Forma to learn how to analyze the site, then bring and their knowledge to the design studio, then use the software to analyze their site uh, in a more appropriate and accurate uh, format, which gives them some numbers or a better idea what's going on in the sites to come up with the better designs. And of course, that's only work for the first stage of the design. The Autodesk Forma use different modules for the analysis. It has sun hour analysis, wind analysis, microclimate analysis, solar energy analysis, energy operation analysis, uh, embodied carbon analysis, shadow analysis, um, and stuff like that. So students at that time, Autodesk Forma didn't have the modules like the embodied carbon analysis. So they didn't conduct any analysis which related to the embodied carbon. However, they mainly focus on the sun hour, microclimate, wind analysis, solar energy, and of course, noise analysis. Uh, for some of for the all those environmental aspect, uh, the Autodesk Forma use the weather data file for a specific location. So uh, all the data comes from the weather data, except the noise analysis, which comes from some numbers that the students understand from those some research and some findings on the internet. For instance, in this slide, you can see a microclimate analysis for the project. The first step in the ADT 241 is that students analyze a site with no mass, with no actually concept or proposal. So they understand that, for instance, how is the sun path, what's the direction of the wind, and what's the noise analysis, what's the microclimate analysis, and which part of the site they can generate more, for instance, electricity from the solar radiation. This slide is all about the sun hours. So students understand that which part of the site will receive enough solar radiation. For instance, the if their location is a harsh winter, so it's they use conduct analysis in winter to understand for how many hours they can get the direct radiation. For instance, if they need to add the outdoor area or a bus stop, they understand that where those spaces need to be located to receive enough radiation during the winter to avoid the heat loss, or if we have an indoor area, and to also get more radiation when they are outside. As I said, the only module that the students need to input their own information is the noise analysis. For instance, in this slide, you can see that the students start to add the noise, the information for the roads next to the site to understand the site behavior in terms of the noise analysis. For instance, here, as you can see, there are two major, not actually major, there are two roads both sides of the site. And based on the input they added, they understand that, all right, so mm, they still have a great opportunity to uh, assign zones that take the advantage of the calm and peaceful environment. And you can see that the current area, the noise is less than 55 decibel. And in the legend also, you can see that 43% of the whole site is below the 55 decibel or comfortable. And there's only majority is the yellow, which is kind of a little bit noisier than the green one, which is between 55 decibel through 65 decibel, and 40%, which is not which is not actually tolerable or actually annoying, is above 65 decibels. The point of this using this analysis is that even when we have a road and the average daily traffic is low, so we understand that, all right, even by roads very close to the site, we may don't have any noise or any other pollutions like this around the site. The next step in the ADT 241 is again using the Autodesk format, but this time student add their mass or proposals in the site so they can understand the behavior of the mass when, for instance, we have a wind a specific direction in a specific seasons. And if, for instance, whether their mass create a wind tunnel in their design, so they can start to put their masses and revise it based on the analysis and output. And they can compare the output from the original mass model, original concepts with the revised concepts. So during their design process, they can improve their architectural design based on the outputs here. They also can conduct the sun hour analysis. For instance, if they are in a harsh winter, they can revise their model based on their solar radiation to make sure that their mass receive enough solar radiation. Or even they are their site is in a very a climate like in Arizona or Texas, or generally in a very harsh summer climate condition, they can conduct an analysis that receive less solar radiation. And when they input their masses, as I said, if they understand that, all right, for instance, their masses receive too much solar radiation in a harsh summer climate condition, they start to revise the mass to receive less solar radiation and have more shade on the envelopes. They also understand how to conduct a solar radiation map on the PV panels. For instance, in a specific direction, in a specific climate condition, to understand what's the best angle for the solar panels to receive more solar radiation. So in an assignment, the students start to have a solar panels with a 0 degree or totally horizontal, and start at 5, increase the angles in 5 degrees. So they did the analysis in 0 degrees, 5 degrees, 15 degrees, through 35 degrees. And they understand which angle is the best angle for the PV panels will receive more solar radiation. For instance, in this slide, the angle of 30 degrees for the PV panels is the best because they receive more solar radiation. So instead of just saying that, all right, so as a student in the reviews, say, I added some PV panels on the roof to have more solar radiation. This is not acceptable anymore in the class because the students have skills to find the best angle and the best location also for the PV panels. So they actually dig into more details with the sustainability. The further step of the ADT 241 or Environmental System for Architectural Design is using another software, say Climate Studio, which is an add-on installed in Rhino. I would like to also mention a challenge here I had in the class. Uh, we had a challenge like some proficiency in some softwares. As I said, the Climate Studio is an add-on in Rhino, and the students have to skills in Rhino to conduct those analysis through Climate Studio. Uh, so I assigned 2 classes for introducing and teach Rhino to my students. Uh, and some students previously in the previous courses had a chance to be introduced by the other instructors with Rhino, but some of them didn't have any chance to work with Rhino before. That's another challenge. So because I need to make sure, I had to make sure that we had to actually make sure that the all the students have a proficiency in Rhino actually in a basic level at least. So uh, I could assign 2 classes for taught Rhino. However, I introduced students some resources to like YouTube video to watch them and become more proficient, become more proficient using Rhino. Uh, anyway, so the third step was using Climate Store, as I said, which is an add-on in Rhino, and they start with the daylight availability. For instance, they understand how to bring more daylight into their projects. Uh, and I would like to also teach my talk about our teaching style in the ADT 241. So in ADT 241, we talk about some concepts in the softwares in a PowerPoint or in a lecture format. And after that, I ran the application in the class. And while I was working with the application, I taught the students how they can use it and create an output from the applications. Like the Climate Studio here. And I also always recorded my classes and included to our LMS, the learning management system actually, which is the Ultra Blackboard. So students have a chance to watch the classes after the class, and if they have any questions, so they can solve their question by watching the videos, which was very helpful for the students. So that's the general my teaching style in this course. Anyway, the furthest step was a Climate Studio. Here, the students ran the daylight availability, and you can see that, for instance, here the SDA is 82% and the ASC is a 94% I asked the students that the SD at least should be 75% and the ASC should be less than 12%. So the students try to add some strategy to reach out those uh, numbers, like using lighting shops or changing the glazing material or using the vertical frames or horizontal frames outside next to the windows to decrease the ASC. And here you can see also that in this picture, you can see the average logs for a building. And that building just comes from, and actually, uh, it was a part of the resources in the class, and I gave the students this model. But at the end of the class, they have a final project, and they do all the analysis based on their final project, which comes and the project, the building comes from the design studio. Here is the students also conduct some analysis, for instance, the electrical radiance render, and to figure out, for instance, what's the electricity density in the rooms, and how many fixtures, electrical fixtures, for instance, they need to reach the appropriate logs in the spaces. So here you can see that they use the electrical radiance render to make sure that they have enough electricity or electric light on the different workspaces. They also did the same for the daylight radiance. And for the daylight radiance, they need to input the time, they need to input the date, because for every single, I can say the second, the sound power, we have a different sound power. So here you can see that the students conduct the daylight radiance render at 7:45 p.m. in June. Unfortunately, I forgot the date of uh, they conduct this analysis. I'm not sure which day of June they conduct this analysis here. So they also understand that and make sure that they don't have any glare on the different surfaces. Now, it's actually, as you can see that the highest locks here in this picture on the chair, I believe so, which is 879. And if you ask why we have it in the chair, because the light that comes from one of those walls, and we have a direct sunlight. But uh, since that direct sunlight, the elevation angle is very low, we it's only 879 lux. However, I believe that the students use some vertical frames for outside to decrease or decrease actually the intensity of the solar radiation to make sure that they don't have any glare, and that's why it's still 859 lux. By the end of the classes, so when the students have all the skills in Autodesk Forma and the climate study and also other applications, they start to uh, apply their knowledge in their design studio projects. For instance, I just selected one of the students' project here, and as you can see, the student used site analysis that comes from the climate studio. They understand which the part of the year they have a wind, and a great option here is that they also understand during the winter which direction they have a wind, and during the summer on which direction they have a wind. So they understand which direction need to be blocked or which direction the wind needs to be getting to the buildings to elevate the natural ventilation inside the building. And they also can study the sun path based on their project. Here, that's a max of the one of the students' project. Now that is format, they study the daylight potential. So again, when they import that into the Autodesk format, they have a chance to revise it to have more daylight. They also did the noise analysis based on their site in their design studio to understand which part side, for instance, are more comfortable to have some zones, or if they want to have an outdoor area, which part is better than the rest of the sites. So here you can see that based on the average daily traffic, they didn't have any challenges with the noise in their site. They also did their own daylight availability, ASCA, average likes in their design. So they understand on which part of the building they have a glare, which part of the building they need more daylight. And as you can see, 82.8% of those area in this project receive sufficient daylight. And the ASA, which is the cause of the glare here, is only 10%, which is great. And the average light is 7,198. Of course, uh, that's for the specific area, which is a lot. So the students have to use some strategy to decrease or actually control this huge amount of daylight in their buildings. Another option for the climate studio is the thermal analysis. So they also model the whole buildings and conduct a thermal analysis. And as you can see that the baseline for the energy EUI is 237 kilowatt hour per square meter. And but based on the material they use, because they also use other application to design a wall based on the R value and U value. And they also bring enough daylight to turn off the electric light during the day. And they also use more efficient mechanical system like the heat pump with the higher, efficiency. So their actually the site EUI is 68 kilowatt hour per square meter. So they start to save the energy about 75%, which based on the what they have. So again, that buildings comes from their design studio, and bring their knowledge in ADT 241 to ADT 244, which is a design studio class. Of course, I also did an anonymous survey by the end of the class. So as you can see, 75% of the students was angry or strongly angry that they feel confident applying theoretical knowledge in theoretical knowledge of the sustainability in the design studio. And 80% of the students find the concept of the sustainability in the 8241 are clear and understandable. And however, still the 10% of them disagree that their materials clear, so they may need more resources or more time to make sure that they are still able to bring their knowledge into the design studio courses. 85% of respondents also say a clear connection between the course and the actually the design studio, because in the class I always mention that there is the connection between this lecture course and the design studio course. And also we also have a communication, all the instructors in the lecture courses and the design studio courses. So also the other instructor in the design studio understand that and learn that what was going on actually in the lecture course. And 80% of the students feel encouraged to think critically, indicating the curriculum's effectiveness. And the 15% neutral suggests some students might benefit from more explicit critical thinking exercise. So 80% of the respondents find the resources helpful, and the resource I used was the applications. And as I said, I always record the classes and put it on Blackboard or through Blackboard, so students have a chance to watch them later and find their answers after the class. There are also 75% of the students feel confident. Uh, Actually, as I said, sorry, that was a uh, redundancy here. I talked about this in the previous slide. And 60% of the students believe that the time frame is sufficient. I mean, the time frame of the class to learn some sustainability knowledge, while only 20% disagree or strongly disagree about the time that they have in the ADT 241. I also need to mention that the ADT 241 is a 4 credit hours, and the meeting time during a week uh, was about actually 4 hours per week. 85% of students also see sustainability as a core principle, reflecting a strong acceptance of its importance in architecture. The students also had a chance to have a lecture from some practitioners and bring their sustainability into the class, and so they understand that even these days they have made there are a lot about sustainability is in architectural firms. And 50% feel fully confident using the knowledge and skills the students gain in ADT 241 in their design studio, while 35% are somewhat confident, and the 15% lack of confidence highlight a need for more practical application opportunities. And 60% of the proficient or very proficient about the tools and the skills they learned in the ADT 241, but 40% are only some what proficient or not proficient, indicating a need more training in simulation softwares. I believe that comes from the proficiency in the Rhino, which is only a modeling class. What I learned is that from this course is that maybe uh, it would be better to have this course while their students are in the third year. However, um, if they start to learn it in the second year, they can start to use their knowledge in their third year. So they should be also analyze if the second year is better, is the best place to teach those stuff to the students, or the third year. This they need to be practiced and uh, need to be examined. Um, Thank you so much. I hope that report was helpful. And the point of this report is that to make sure students can bring their sustainability knowledge in the design studio rather than just talk about very basic, like only the sound path in the design studio. Thank you so much.